Hi, dear students. We are going to discuss the most important questions from the chapter Carbon and its Compounds, which were asked in the previous board exams. As you know, this chapter is a very important chapter in chemistry, which is not only important for your 10th board examination, but also lays the foundations for organic chemistry in 11th and 12th. So, let's discuss the most important questions and the related concepts from this chapter. So let's move on to question number 1. Right. The first question is, ethanol reacts with sodium and forms two products. These are. See, this is a question asked from the chemical properties of ethanol. You know that you have two important compounds whose chemical and physical properties need to be covered in this chapter. One is ethanol and the other one is ethanoic acid. So, ethanol, you know that it is the second member of the homologous series of alcohol. The first member being methanol, which is CH3OH. Ethanol is CH3CH2OH. And it is an alcohol. You know that every compound which contain the functional group OH is called as alcohol. So, when ethanol reacts with sodium, that is what is asked in this question. You all know that ethanol will react with sodium to form CH3CH2ONA plus H2. CH3CH2ONA is called as sodium ethoxide. Sodium ethoxide. So, when ethanol reacts with sodium, we can say that sodium ethoxide and hydrogen gas is formed. So, they asked the two compounds or the two products which are formed in this reaction are sodium ethoxide and hydrogen gas. Let me tell you a very important point from this question, which is most of the times the most common error that you may commit is the product which is formed during this reaction. Because you also know that instead of ethanol, if you take ethanoic acid, which is CH3COOH, if this reacts with sodium, you get CH3COONA plus H2. So you should not have a confusion between this compound and this compound. This is sodium ethoxide, while this is called as sodium ethanoate. Sodium ethanoate, or we can also call it as sodium acetate. So please keep this point in mind when you answer any question related to the reactions of ethanol and ethanoic acid. Right. So let's move on to the next question. The structural formula of cyclohexane is, as the name suggests, cyclo, which means it will be a closed ring-shaped compound, and hexane stands for 6 carbon containing compound with only carbon-carbon single bonds. So the structural formula of cyclohexane, you can see in option A, there is a double bond between carbon and carbon. Here there is a triple bond. And in option D also, you can see double bonds. So the only option where there is only single bonds between carbon atoms and there are 6 carbon atoms arranged in the form of a ring is option B. So this will be the right answer for the question. And all of you must remember that this belongs to cyclic compound, where you have 6 carbon atoms in the form of a ring. So if you look into the formula of this, you can see there are 6 carbon atoms, and on each carbon atom there are 2 hydrogen atoms. So that makes the molecular formula of cyclohexane C6H12. And if you look into the pattern of the formula, it belongs to CnH2n kind of category, correct? where n is the number of carbon atoms. You also studied that this formula fits best for alkenes as well. What are alkenes? Hydrocarbons which has at least one carbon-carbon double bond. That is called as alkene. So remember that cycloalkenes and alkenes, they both are isomers and they both have the same formula CnH2n. So this is an additional point which is very, very important. So I hope this question is very clear to everyone. This was a very recent question. It was asked in CBSE 2024 exam. Right. So let's move on to the next question. Consider the structures of the three cyclic carbon compounds 1, 2, and 3 given below and select the correct option from the following. So you can see that this is a cyclic compound where there is only single bonds between carbon atoms. Whereas this compound has single bond as well as double bond. And you can see that it's alternate double bonds, right? So this is basically benzene and the first compound is cyclohexane. Now, in the next compound, you can see this also has two double bonds and 1, 2, 3, 4, 5, 6 carbon atoms. So it is also a cyclic alkene. Now let's read the options. The first option says 1 and 3 are isomers of hexane and 2 is benzene. See, 1 is cyclohexane. You know that cyclohexane has a formula C6H12, whereas the normal regular hexane has a formula C6H14. This is an alkane, whereas this is a cycloalkene. You know that if the molecular formula is not same, they are not isomers. As you have already studied the definition of isomers as compounds that have the same molecular formula but different structural formula. So option A is wrong. Option B says 1 is an isomer of hexane. That is again wrong because they can't be isomers as long as their formulas are not same. Option C says 1 is a saturated cyclic hydrocarbon. That is correct because it is a cyclic compound and it has only carbon-carbon single bonds. So that is a correct statement. And 2 and 3 are unsaturated cyclic hydrocarbons. Very much true. Because in second compound and third compound, you have carbon-carbon double bonds that makes it unsaturated. So option C is a correct statement that describes the structures. So we can select option C as the right answer. Option D is also wrong. You can see it is written 1 is cyclohexane and 2 and 3 are isomers of benzene. No, this is benzene, but this is not benzene because you know that in benzene you need 3 alternate double bonds. But here we have only 2 double bonds. So this is not an isomer of benzene. So I hope this question is clear to everyone. This was asked in CBSE 2023. It's a very, very important question. You all need to remember the structures of these compounds. Right. Now, we will look into another board question. The question is, a student took 4 test tubes, P, Q, R, and S, and filled about 8 ml of distilled water in each. After that, he dissolved an equal amount of sodium sulfate in P, potassium sulfate in Q, calcium sulfate in R, magnesium sulfate in S. On adding an equal amount of soap solution and shaking each test tube well, a good amount of lather will be obtained in the test tubes. This is a very simple application level question if you know the properties of soap and how it behaves with different types of water, right? You know that water are of 2 types, soft water and hard water. Soft water mainly contains sodium and potassium salts, whereas hard water contains calcium and magnesium salts. So the problem is that when we add soap molecules into water that contains calcium salts or magnesium salts, they are going to react with soap molecules and forms a white colored precipitate called scum. So this scum do not let the soap molecules to form micelles, and it will precipitate at the bottom of the container or the boilers. So at that time, we will not see as much lather as how soap behaves in regular water or soft water. So this is the key concept that you have to apply here. So you can see that in the test tube P, sodium sulfate is added. In the test tube Q, potassium sulfate is added. See, in both those test tubes, since they are sodium and potassium salts, soaps will not have any difficulty in forming lather. But the test tubes R and S contains calcium sulfate and magnesium sulfate in them. So this will result in formation of scum, and there will be no lather formation in those two test tubes. So here the question is, a good amount of lather will be obtained in the test tubes where you will have sodium and potassium salts, right? So our options will be the test tube which is having sodium sulfate and the test tube which is having potassium sulfate will have enough lather. So P and Q will be the right choice in this case, right? So I hope the concept behind this question is clear to everyone. So this is one of the most frequently asked question. Soap molecules are ineffective in hard water because they react with the ions like calcium and magnesium present in hard water to form a white colored precipitate called scum. Right. So let's move on to the next question. Which of the following are correct structural isomers of C4H10? Again, I told you isomers are compounds that have same molecular formula, but they have different structures, right? So here the question is C4H10. See, for C4H10, I can think of mainly two skeletons. One is all the 4 carbon atoms are in the straight chain, and another one is 3 carbons in the parent chain and 1 carbon as a branch. Correct? So these are the two skeletons which I can think of when I say the formula C4H10. So in this compound will have the structure like this: CH3, CH, CH3, CH3. And you know that this compound is called as 2-methyl propane, or in common names we can call it as isobutane. Isobutane. This can be an isomer of C4H10. Yes, because it has the formula C4H10. And then we have CH3, CH2, CH2, CH3. This is straight chain of 4 carbon atoms, so this is normal butane. This also has the same formula C4H10. So these are the two isomers I can think of when the formula C4H10 is written. So look into the options. The option 1 has straight chain structure which is similar to N-butane. Yes, so it is an isomer. Option 3. In option 3, you can see that there is a cyclic bonding here. So this cannot be an isomer. Then we have option 2, where we have 3 carbons in the parent chain and 1 in the branching. So this can be an isomer. And option 4 again is a cyclic compound. It has 4 carbons connected by single bonds, but the number of hydrogen atom is only 8. So this is C4H8. So it doesn't satisfy the formula of C4H10. So which are the isomers? We have option 1 and 2. So option C will be the right answer for this. And in fact, if you notice, you can see the frequency of this question. It has been asked a number of times in board exam. So you have to be very clear about the isomer segment, learn the definition, draw the isomers possible for various compounds like C4H10, C5H12, C6H14, like that. So I hope this question is clear to everyone. Right. So let's move on to the next question. CH triple bond CH. Added hydrogen in presence of palladium, and I got a compound X. And this compound X is obtained also by treating C2H5OH with a hot concentrated sulfuric acid. Which of the following correctly represents X in the above chemical changes? Again, something related to the chemical reactions that we learned in the chapter carbon ions compounds, right? So you can see that the first compound is ethine. Ethine is an alkyne. So if you add hydrogen in presence of palladium, you know this reaction is called as hydrogenation or catalytic hydrogenation. It is an example for addition reaction. What do you mean by addition reaction? One of the triple bond will break, one bond in the triple bond will break, and hydrogen will add across it. So what do I get here? I get CH2 double bond CH2, and that's going to be ethine. Sorry, that's going to be ethene. It's an alkene, correct? It's an alkene. Now, that alkene is also obtained by the reaction of ethanol with a concentrated H2SO4. Very true. You have studied one property, dehydration of ethanol. What is dehydration of ethanol? When you add hot concentrated sulfuric acid and heat it at a temperature of 443 Kelvin, you get ethanol. Sorry, you get ethene. So this is an example for dehydration reaction where water is eliminated. So the compound X in this case is going to be the alkene called as ethene. It's a very important reaction. Both the reactions are really important, and it's frequently asked in boards in different types of formats. So be sure about these reactions and know what are the products. Perfect. Let's move on to the next question. The next question is, a student is given equal amount of 3 samples of water with temporary hardness, labeled as A, B, and C. He keeps the 3 samples at different temperatures, A at room temperature, B at 50 degrees Celsius, C at 95 degrees Celsius. Which sample will give maximum amount of lather when 10 ml of soap solution is added to each sample and shaken for equal time? Again, I would say, even though not direct, it's an indirect question related to one of the concepts that you learned. You know, hardness in water, as I mentioned in the previous few slides back, hardness in water is caused by calcium and magnesium salts. One of the way to remove temporary hardness of water is by boiling it. So when you increase the temperature of water, which has a temporary hardness for it, that hardness is going to decrease. And you know that if these ions which causes hardness are removed, or if its concentration decreases, soap will perform better, right? Soap will form more lather. So that is the concept you have to apply here. So you can see that A is kept at room temperature, B is kept at 50 degree, C is kept at 95 degree. So it's obvious that the tube which is kept at a higher temperature will have lesser hardness for the water in it, right? So in that case, the lather formation will be maximum in that particular test tube. So the answer for this question is going to be test tube C, which is kept at a high temperature. So what is the concept that we are using here? Temporary hardness is removed by heating. So if you know this concept, you can apply it and you can easily answer this question. So I hope this question is also clear to everyone. Let's move on to the next question. So it's an assertion reason question. The assertion statement says, esterification is a process in which a sweet smelling substance is produced. So let's read that assertion and see if that statement is correct or not. Esterification, it's one of the most important chemical reaction that we learned in carbon and its compounds. Whenever a carboxylic acid react with an alcohol and you heat it in presence of an acid catalyst like sulfuric acid, we get fruity smelling substances called esters plus water. This reaction is what is called as esterification. And in fact, you have a similar reaction example given in the textbook, which is ethanoic acid CH3COOH reacting with ethanol C2H5OH. When it is heated in presence of an acid catalyst, you get CH3COOC2H5 plus H2O. So here we have an ester formed called as ethyl ethanoate, or we can call it as ethyl acetate, right? So this reaction is called as esterification. So during esterification, a sweet smelling substance is produced is a correct statement, right? So the assertion statement is correct. Now, the reason statement says when esters react with sodium hydroxide, an alcohol and sodium salt of carboxylic acid are obtained. Yes, let's look into that reaction. See, when we treat an ester, for example, if I have the same ester what I took here, CH3COOC2H5, and if I treat it with sodium hydroxide, it's a base, right? So it will result in formation of CH3COONA plus C2H5OH. What is CH3CONA? It is sodium acetate, which is a sodium salt of the carboxylic acid, plus you're getting ethanol. So this reaction is used for the preparation of soaps because soap molecules are having a structure very similar to sodium acetate because soaps are sodium or potassium salts of long chain carboxylic acids, right? So this reaction is indeed used for the preparation of soap and it is called as saponification, right? So the statement in the reason is also correct. But you can see that those two statements are not connected. Whatever reason mentioned in the reason statement is not the reason for the assertion statement. So they are two independent statements. So we can go ahead with the option B. Both assertion and reason are correct, but reason is not the correct explanation of assertion. Right? So I hope this question is clear to everyone. Okay, perfect. So let's move on to the next question. Another assertion reason question asked in 2020 exam. The statement, carbon has a strong tendency to either lose or gain electrons to attain noble gas configuration. Carbon has a strong tendency to either lose or gain. That is not correct because the very basic fundamental thing that we learned in the beginning of the chapter is carbon forms covalent compounds, correct? It neither lose electron nor gain electron because you know that the electronic configuration of carbon atom is 2, 4, which means it has 4 valence electrons. So having 4 valence electrons make it difficult to lose or gain. You have studied the reasons because if you want to lose 4 electrons, the amount of energy required is very high. And if you add 4 more electrons into carbon, the nucleus of carbon is not strong enough to hold on to the extra added electrons. So carbon has no option to lose electrons or gain electrons. So what is the only choice left? Carbon will share its electrons. And you know that sharing will create a type of compound called as covalent compound, and losing and gaining will create ionic compounds. So carbon has least tendency to lose or gain. So that statement in the assertion is wrong. Now let's move on to the reason statement. Carbon has 4 electrons in its outermost shell and has the tendency to share electrons with carbon or other elements. That is a perfect statement, right? It is correct. Carbon has total 4 electrons in its outermost shell, and because of that, it has a tendency to share its electrons either with carbon atom or with other atoms, right? So the reason statement is correct, assertion statement is wrong. So I hope it is clear to all students. Okay, perfect. Now let's look into the next question. What is a saturated hydrocarbon? And write the formula of any one saturated hydrocarbon. So you guys know that there are two types of hydrocarbons, right? Based on the nature of the carbon-carbon bond. So one we have is saturated. For easiness, we say that saturated hydrocarbons are those which has at least which has all the carbon-carbon bonds, single bonds. Then we have the second category, which is called as unsaturated. What is unsaturated hydrocarbon? Hydrocarbons that has multiple bonds between carbon atoms. For example, if at least one carbon-carbon bond is a double bond, or if one carbon-carbon bond is a triple bond, then such hydrocarbons are called as unsaturated. Correct? So even though the terminology saturated and unsaturated is based on something else, I hope you know that clearly. Saturated hydrocarbons are called saturated because they are already saturated with hydrogen atoms and there is no more provision to add more hydrogen atoms. That is why it is called saturated. And in case of unsaturated, for example, if you take an example of ethene, ethene is an unsaturated hydrocarbon. You know that in this case, if I break one of the double bond, I have a provision of adding more hydrogen into it. That's why it is called as unsaturated. So a saturated hydrocarbon can be defined by saying that a hydrocarbon that has only carbon-carbon single bonds. Now write the formula of any one saturated hydrocarbon. Okay, one of the example of saturated hydrocarbon we can say is ethane. So in ethane, there are two carbon atoms bonded by a single covalent bond and the rest valencies are satisfied by hydrogen. So this is an example, or you can write any example if you want, depending on what is your choice. For example, you can write methane, you can write ethane, propane, butane, pentane, hexane, any such compounds can be written as long as there is only carbon-carbon single bonds. Okay, so I hope this question is also clear to everyone. And what is the formula of ethane? Ethane is C2H6. So they asked, write the formula of any one such saturated hydrocarbon. Okay, perfect. Let's move on to the next question. Which oils should be chosen for cooking to remain healthy? It's a 2020 question and it's a very, very important question, I would say. See, you know that there are two types of fats. One is unsaturated and the other one is saturated. So, simple meaning, unsaturated fats are those which contain carbon-carbon multiple bonds and saturated ones are those contain single bonds. See, usually vegetable oils are unsaturated and they are healthy as well. The risk of deposition of these kind of fats in the blood vessels is very less if you have unsaturated hydrocarbons in the oils. For example, we call such compounds as polyunsaturated fatty acids. Polyunsaturated fatty acids. These are health-wise, these are excellent, whereas saturated fats are really bad. For example, most of the animal fats, they are belonging to saturated fats and they are unhealthy. So, which oil should be chosen for cooking to remain healthy? We should select those oils which are containing unsaturated hydrocarbon chains in it. Hope you understood the point. It's clear? Let's move on to the next question. What happens when 5% alkaline potassium permanganate solution is added drop by drop to warm propyl alcohol taken in a test tube. Explain with the help of a chemical equation. So, what happens when 5% alkaline potassium permanganate is added drop by drop to warm propyl alcohol? See, this reaction, as it is, may not be mentioned in the textbook with propyl alcohol, but you do know a reaction where ethyl alcohol reacts with KMNO4, correct? So that is an example for oxidation reaction. So the same is going to happen here. You guys know that propyl alcohol is CH3, CH2, CH2OH, which is known as propanol in IUPAC nomenclature. When we treat this with alkaline potassium permanganate, alkaline potassium permanganate or alkaline KMNO4 is a powerful oxidizing agent, right? So, alcohol will be oxidized into carboxylic acid. That is the chemical reaction going to happen here. So, in this reaction, what is the role of KMNO4? KMNO4 is acting as a oxidizing agent. KMNO4 is acting as a oxidizing agent. Why is it called oxidation? Because if you observe this carbon and this carbon, one thing is clear, hydrogen is removed, correct? Removal of hydrogen. And you can see that oxygen is added. Oxygen is added, correct? Removal of hydrogen or addition of oxygen. What is this called as? This is known as oxidation, correct? You have studied that in redox reaction segment in the first chapter, right? Okay, so the product formed will be propanoic acid. The name of this acid is propanoic acid. Propanoic acid. So we can say when propanol is treated with alkaline KMNO4, it will be forming propanoic acid. So I hope this question is clear to everyone. So do remember the general reaction. The general reaction is when alcohols are oxidized, you get carboxylic acids. So next time in the next board exam, if they ask you what happens when butanol is treated with acidified potassium dichromate, you can say it's going to form butanoic acid because butanol is also an alcohol and acidified potassium dichromate is similar to alkaline potassium permanganate in terms of its chemical action. They both are excellent oxidizing agents. So I hope it is clear to everyone. Okay, perfect. Now, let's move on to the next question. The formula of 4 organic compounds are given as following. P is having a formula C2H4, Q is having a formula CH3COH, R is having a formula C2H5OH, S is C2H6. Now the question is, which one of these compounds P, Q, R or S is a saturated hydrocarbon? You guys know that saturated hydrocarbon means we are referring to alkanes, correct? So saturated hydrocarbons are basically alkanes. And what is the general formula of all alkanes? Every alkane has a general formula CnH2n plus 2, correct? So in this case, the only formula that fits in CnH2n plus 2 is the compound S, correct? So S is having a formula C2H6. So here the N value is 2, correct? So if you put N value as 2 here, it will be C2H2 into 2 plus 2 is 6. So the only saturated hydrocarbon among the 4 compounds is S. So I hope the answer for A part is clear. Then we have the next part. Identify the organic acid and give its structural formula. You know that organic acids are generally represented by the structure RCOOH. RCOOH. So what should you look for an organic acid? The functional group is COOH, correct? This is the functional group called as carboxylic acid group, correct? Carboxylic acid group. So who is the compound that contains carboxylic acid? You can see that the formula Q corresponds to CH3COOH, which has the same formula as the general formula of carboxylic acid. So we can say Q is a carboxylic acid, right? And give it structural formula. Structural formula means you can just expand the structure of CH3COH and write it. So it's going to be CH3 single bond C double bond O OH. This will be the structural formula of carboxylic acid, that is ethanoic acid. This compound is known as ethanoic acid in IUPAC nomenclature or acetic acid in common nomenclature. Clear? Right. It was a 2019 question, and this has been asked many other years as well in different formats. So, remember, it's one of the most important questions. So, I hope this question is also clear to everyone. Perfect. So, let's move on to the next question. Two carbon atoms cannot be linked to each other by more than 3 covalent bonds. Why? See, again, I would say an application level question. So the concept behind that is very important. You guys can see when carbon and carbon is forming a single bond, there is sharing of one pair of electrons. When carbon and carbon is forming a double bond, there is sharing of two pairs of electrons. When carbon and carbon is forming a triple bond, there is sharing of three pairs of electrons. See, every time when I say sharing, you must understand that these atoms are coming closer and they are overlapping their atomic orbitals so that they get bonded. So, more the number of electrons that they share, more will be the extent of overlapping. So, what you need to understand here is the single bond between carbon and carbon, let's say it has some distance between carbon atoms. Double bond will have a little more lesser distance because double bond has more number of electron sharing happening. As a result, they will be more closer to each other. A triple bond will have more proximity, or the distance between the two carbon atoms in a triple bond will be lesser compared to double bond or single bond. So a triple bond is already having two atoms in the close proximity. Now, if you try to make a sharing which happens by sharing of four pairs of electrons, you know what will happen is when the atoms cross a particular point, when they are more and more closer and they cross a particular point, instead of attractive interactions, repulsive interactions will operate. So repulsions will become more predominant and that will weaken the bond. That is the reason why the highest degree of bond that can form between any two atoms is a triple bond. So please do remember this concept. The reason why more than 3 covalent bonds are not formed between any two carbon atom is because of dominant repulsive interactions when the atoms come closer to each other. So I hope this concept is clear to everyone. Okay, let's move on to the next question. Raina, while doing certain reactions, observed that heating of a substance X with vinegar-like smell with a substance Y, which is used as an industrial solvent, in presence of concentrated sulfuric acid on a water bath, gives a sweet-smelling liquid Z, having molecular formula C4H8O2. When heated with caustic soda, Z gives back the sodium salt and the compound Y. Identify X, Y, and Z and illustrate the changes with the help of suitable chemical equations. See, in such questions, the hint to identify the compound will be there in the question itself. You can see when Raina, while doing certain reactions, observed that heating of a substance X with a vinegar-like smell. So X is having vinegar-like smell. So X is going to be acetic acid, right? Plus, it is heated along with a substance Y, and Y is used as an industrial solvent. One of the most frequently used industrial solvent is ethanol, C2H5OH. So they both are heated in a water bath in concentrated sulfuric acid. It resulted in formation of a compound with the formula C4H8O2. And this compound is a sweet smelling compound. So we got to know what is it. We studied that when carboxylic acid is heated with alcohols, it results in formation of esters. So here we will get CH3COOC2H5, which will be the compound Z plus H2O. And then they said, when heated with caustic soda, Z gives back the sodium salt and the compound Y. That is again true because we know that in saponification, CH3COOC2H5, which is an ester, that reacts with NaOH. What will happen? What will happen when this is heated? This will form CH3COONA plus C2H5OH. We got back the compound Y. The compound Y was ethanol, and this reaction is saponification. So it's very easy to do these kind of questions provided you are thorough with the concepts and the reactions in that chapter. So the first reaction that I illustrated here is called as esterification, whereas the second reaction is saponification. So this is esterification and this is saponification. Right? So this question is also clear? Okay, perfect. Now let's look into the next question. A gas is evolved when ethanol reacts with sodium. Name the gas evolved and also write the balanced chemical equation of the reaction involved. This is something that we did in the first part of the discussion. You know, a alcohol like C2H5OH, when it reacts with a metal like sodium, what does it form? C2H5ONA. And I told you that C2H5ONA is called as sodium ethoxide plus hydrogen gas. This will be the gas liberated. So when you balance this equation, this will be 2Na, 2C2H5ONA plus H2. So write the balanced chemical equation of the reaction involved. So we can say when ethanol reacts with sodium, it forms sodium ethoxide and a gas is liberated, and that gas is hydrogen. So the bubbles that carry this gas when brought near a matchstick will burn with a pop sound, right? Okay. Now, let's go on to the next question. How many isomers are possible for the compound with the molecular formula C4H8? Draw the electron dot structure of the branched chain isomer. So, by looking at the formula, we understand one thing. C4H8. This formula can be the formula of an alkene, or it could be a cycloalkane. Right? So, in this, the possible structures that I can draw for this formula are the first one, CH3, CH2, CH double bond CH2. This is one possibility. This is butene, or we can call it as but1ene. Then I can draw another structure which can have a formula like this or a structure like this, where the double bond's position is different. This can also be an isomer because the position of the double bond will change the compound. The first compound is but1ene and the second compound is but2ene. You can see that but1ene and but2ene both are isomers. Then I can think of another compound, CH3, C double bond CH2, single bond CH3, a branched isomer. This is also possible because as long as the formula is C4H8 and the compound structure is different, they all are isomers. And another possibility is I can even think of the cyclic compound here, which is cyclobutane. So all these can be isomers of C4H8. And they asked draw the electron dot structure of the branched chain isomer. So among this, the branched chain isomer is this compound CH3, C, CH3, double bond CH2. And they asked us to draw the electron dot structure. You guys know that in electron dot structure, we don't show the bonds. Instead, we show the electrons. So let's make it into electron dot structure. So let's say I'm going to represent the electrons of carbon, hydrogen with the dots. So each hydrogen has one electron, correct? Each of them have one electron. Now let me show the electrons of carbon with the cross. 1, 2, 3, 4. That's for the first carbon. Then 1, 2, 3, 4. That's for the second carbon. 1, 2, 3, 4. That's for the fourth carbon in the branch. And 1, 2, 3, 4. That's for the last carbon. So this is how you make the electron dot structure. Make sure that every atom has attained a doublet or an octet. For example, if you look into hydrogen atom, this hydrogen has got 2 electrons, this hydrogen has got 2 electrons, this hydrogen also has got 2 electrons, this hydrogen has 2, this hydrogen has got 2, this has got 2. So all the hydrogen atoms are now stable. Now looking into carbon, every carbon must have 8 electrons. So look into this bond, here I have 8 electrons. Look into the next carbon, it has again 8 electrons. Then here 8 electrons. So all the carbon atoms must have 8 electrons total. That is the condition for octet, right? Yes. So this is the electron dot structure of the branched chain isomer. Now, look into the B part of the question. The B part of the question says, how will you prove that C4H8 and C5H10 are homologues? Homologues. You guys remember homologues or homologous series. What is the definition of a homologue? A homologous series refers to series of hydrocarbons or carbon compounds which has the same functional group, or they all will have the same chemical properties because they have the same functional group, and adjacent members of one series will differ by one CH2 group, correct? For example, they are C4H8 and C5H10. See, C4H8, I can draw the structure as CH3, CH2, CH, double bond CH2. This is C4H8, butene. And then the next formula is C5H10. I can draw its structure as CH3, CH2, CH2, CH double bond CH2. So look into both these structures. You can see that these two structures differ only in one extra CH2 group, correct? So we can say these two compounds differ by one CH2 group. That is one criteria. And they have a difference of 14 unit mass, and they have the same functional group. What is the functional group here? In both these compounds, the functional group is double bond, correct? It's alkene. They both are alkenes. So these many criteria are enough to say that they both are homologues, because all the homologues must have same functional group. They will differ in their physical properties, but they have same chemical properties. Adjacent members of a homologous series will differ by 14 units of atomic mass or by one CH2 group. These are the conditions of homologous series or homologs. So I hope this question is very clear to everyone. Perfect. Now, let's go to the next question. A carbon compound A having a melting point of 156 Kelvin and boiling point 351 Kelvin with molecular formula C2H6O is soluble in water in all proportions. Identify A and draw its electron dot structure. So that's the first part. Okay, so while reading the first part of the question, it's very clear. A carbon compound A having melting point 156 Kelvin and boiling point 351 Kelvin with molecular formula C2H6O. By looking at that formula itself, it is very evident that it's an alcohol because you can see there is only one oxygen, right? It's not an acid, it's an alcohol. And it is soluble in water in all proportions. So identify A. So A is going to be ethyl alcohol or ethanol because there is only one alcohol which has two carbons and that is ethanol. And draw its electron dot structure. So again, how will we draw the electron dot structure? We show the electrons sharing of each of the atom involved. So we have CH3, CH2, OH. So let's say hydrogen has one electron each. Then I have carbon 1, 2, 3, 4. For this carbon is complete. Next carbon is 1, 2, 3, 4. And then I have oxygen. So for oxygen, it will share one electron here and one electron here. Rest of the electrons of oxygen will be unshared. We call it as lone pair of electrons. So you can see that oxygen total has how many electrons? 6 electrons are there. So one electron is shared here, single bond. One electron is shared here, single bond. And these two electrons are unshared. So they are called as lone pairs. Lone pairs. Okay, perfect. Now, give the molecular formula of any two homologs of A. Any two homologs of A, its molecular formula. So you guys know that alcohol has a functional group OH. So the homologous members of this family would be, you can say methanol is there. What is the formula of methanol? CH3OH. You have propanol is there, which is CH3, CH2, CH2OH. So these are all homologs of ethanol. Methanol, ethanol, propanol, butanol, pentanol, hexanol, all of these are alcohols, the family of alcohols, because they all have an OH group as the functional group. Is it clear? Right. So let's move on to the next question. Again, a bit longer one, but it's an easy question. A carbon compound P is found to be neutral when tested with the red and blue litmus. A gas that burns with a pop sound is produced when a metal reacts with the carbon compound P. See, when we read this much, we get the hint. It should be an alcohol because it says it's neutral with pH, with the red and blue litmus. That means it's not going to be a carboxylic acid, it should be an alcohol then. And it reacts with a metal and it produces a gas that burns with a pop sound. So obviously it is alcohol because the gas is going to be hydrogen reacting, ethanol reacting with sodium forms hydrogen. We have seen that in a couple of questions before. So first thing, write the chemical equation for the reaction. So the first reaction is what we wrote before, C2H5OH plus Na is going to give you C2H5ONA plus H2. Correct? This is the chemical equation. So 2 moles of this, 2 moles of this, 2 moles of this will give 1 mole of hydrogen gas. And then second, the carbon compound P is heated with concentrated sulfuric acid to produce carbon compound Q. So who is P here? P is ethanol. So CH3, CH2, OH. When it is heated with concentrated H2SO4 at 443 Kelvin. We studied that this is called dehydration reaction because it involves removal of water from ethanol. And we get a compound called Q. Who is Q? Q is ethene, right? Q is going to be ethene. Now, that is B part. So, write the chemical equation for the reaction and describe the type of flame that Q on combustion produce. See, Q is an alkene, correct? Alkene is unsaturated. So, we studied that unsaturated hydrocarbons on combustion will burn with a sooty yellow flame, right? Because there will not be complete combustion undergoing, so there will be unburnt carbon particles, which makes the flame sooty, means a lot of carbon deposits will be there and it's yellow in color. Whereas saturated hydrocarbons is going to burn with a clean blue colored flame, right? So this part of the question is clear. Now we have one more segment in that question. It's a long answer question. So what is likely to be observed on heating compound P with ethanoic acid and an acid as a catalyst? Write the chemical equation for the reaction. We already looked at it, correct? When P, that is C2H5OH, when it is heated with ethanoic acid is CH3COH. When you heat it with concentrated sulfuric acid, it will form CH3COO C2H5 plus water. This reaction is esterification. So, the chemical equation involved in esterification is this. So, you can see the frequency of this particular part in the board examination. So, compounds of ethanol, the properties of ethanol and ethanoic acid, those reactions are really important. So, be thorough with that topic and you're going to get really good scores. Right. Let's discuss the next question. A saturated organic compound A belongs to the homologous series of alcohols. On heating A with concentrated sulfuric acid at 443 Kelvin, it forms an unsaturated compound B with a molecular mass 28 unit. The compound B on addition of 1 mole of hydrogen in the presence of nickel changes to a saturated hydrocarbon C. Identify ABC. See, it's a very important question and at the same time very easy one as well. First, it says a saturated organic compound A belongs to a homologous series of alcohols. So one of the most common alcohol that we learned is ethanol. So CH3CH2OH is the formula of ethanol. So that could be A. And this on heating with the sulfuric acid at 443 Kelvin, it forms an unsaturated compound B. So you know that ethanol on heating will undergo dehydration to form ethene, correct? Ethene. So this is the compound B is going to be ethene. And its molecular mass is 28. Let's verify. Carbon is 12. There are 2 hydrogens, so plus 2, plus another carbon is 12, plus 2 hydrogen. So 12 plus 2 is 14, 14 plus 14 is 28. So the molecular mass is matching. The compound B on addition of 1 mole of dihydrogen. So if you add hydrogen into an alkene in presence of nickel, it will change into a saturated hydrocarbon. True, the saturated hydrocarbon that you're going to get is this compound. What is its name? It is ethane. It's an alkene, correct? So we identified who is A, B, and C. Now, the second part of the question is write the chemical equation showing the conversion of A to B. So A to B conversion is what is shown here. This is the dehydration reaction where we get ethene. Then the C part of the question, what happens when compound C undergoes combustion? You know, compound C is C2H6. So undergoing combustion means what? It is going to react with oxygen, or it is going to burn in air, right? So I can show the reactions. C2H6, when it undergoing combustion, it's going to produce CO2 plus H2O plus a large amount of energy is released, because you know that combustion of hydrocarbons will release carbon dioxide, water, and a large amount of energy. And since this is a saturated hydrocarbon which you are burning, it will burn with a clean blue colored flame. So that is the observation you have to write here. What happens when compound C undergoes combustion? When compound C, which is ethane, undergoes combustion, it burns with a clean blue colored flame and it liberates carbon dioxide, water, and a lot of energy. That will be the answer for the question in the C segment. Now we have D. State one industrial application of hydrogenation reaction. You all know that hydrogenation reaction is used for conversion of vegetable oils into saturated fats, right? Into saturated fats. This is the industrial application of the hydrogenation reaction. We can convert unsaturated vegetable oils into saturated fats. Name the products formed when compound A reacts with sodium. We already discussed that a lot number of times. Compound A is ethanol, and ethanol reacts with sodium. What is the name of the product? It will form CH3CH2 ONA, which is called as sodium ethoxide. Sodium ethoxide. Right. Now let's move on to the next question. An organic compound P is a constituent of wines. P, on reacting with acidified K2Cr2O7, forms another compound Q. When a piece of sodium is added to Q, a gas R is evolved which burns with a pop sound when a burning matchstick is brought near it. So by this time you will be completely confident of all the reactions that is happening here, and you might have already identified every compound involved in this reaction, right? Because the first part clearly says an organic compound P is a constituent of wines. So in wine we have the compound ethanol. Ethanol. So this is the compound which is represented as P. Then the B part of the question says, mention another use of the compound P apart from the use mentioned in the question. You know that ethanol is used as an industrial grade solvent, right? And it is used in medicine for making tonics, syrups, etc., right? Tincture of iodine is one example. So these are all applications of ethanol. Then illustrate with the help of chemical equation conversion of P into Q. P is ethanol and we are treating it with acidified K2Cr2O7. So how can I write an equation for that? CH3 CH2OH when treated with acidified K2Cr2O7, which is a strong oxidizing agent. And what do I get? I get acetic acid, right? So P getting converted into Q is like this. It is an example for oxidation reaction. Again, something directly from NCERT textbook, right? Then, give a balanced equation to depict the reaction of Q with the sodium. Again, the D part, balanced equation to depict the reaction of Q with the sodium. So Q is CH3COOH, correct? Plus sodium. So metal plus acid will give you salt plus hydrogen. So CH3COONA plus hydrogen. What is that called? Sodium ethanoate or sodium acetate. That will be the compound formed. Then the last question is, what happens when P is heated with concentrated sulfuric acid at 443 Kelvin? Write its chemical reaction. Again, a reaction which we are already thorough about. What is that? Ethanol, CH3CH2OH on treatment with concentrated sulfuric acid at 443 Kelvin will undergo dehydration to form CH2 double bond CH2 plus H2O. This is the reaction. So it's an important question. It's a very important area. It covers so many reactions. So please be thorough with these concepts. Right. Next, we will see another question, which is a very important one and an application level question. A child draws the structural formula of 4 carbon compounds as shown below. Which of the following compounds are likely to have similar chemical properties? So, when you read a question at that time, there are some part of the question which you need to focus. And here in this question, this is the part that you need to focus. They are likely to have similar chemical properties. So, when you think about that, you will understand similar properties are exhibited by compounds that have the same functional group, right? So, here look for the same functional group. In compound 1, this is C double bond O. C double bond O is ketone, correct? In compound 2, it is OH group, so it is an alcohol. Then here also CHOH, this is an alcohol. And here it is COOH, which is a carboxylic acid. So who will have similar chemical properties? Compounds that have the same functional group, correct? So 2 alcohols will have same functional group. So they will have same properties. So our options will be 2 and 3 are going to exhibit same chemical behavior because they both have the same functional group, that is OH. Clear? Right. The next question. Hydrocarbons of X and Y have the general formula CnH2n and CnH2n minus 2. From here itself, it's very clear that this is an alkene and this is an alkyne, correct? They are hydrogenated in the presence of either nickel or palladium catalyst. Which one of the following options shows the number of moles of hydrogen required to completely saturate 1 mole of compound X and Y? Okay, that's a very easy question. At the same time, an important one as well. CnH2n, that formula corresponds to alkene, correct? So alkenes have only one double bond, right? So when you hydrogenate it in presence of nickel, all you need is 1 mole of hydrogen, correct? 1 mole of hydrogen. What will happen? It will break the double bond and hydrogen will add across it. But at the same time, if I have an alkyne, the formula of alkyne is CnH2n minus 2. So in this, there is a triple bond. So if I have to hydrogenate it completely, you know that 1 hydrogen is not sufficient. I need actually 2 mole of hydrogen in nickel. Then only I can sequentially break it, because when one of this bond break, 1 hydrogen is added. Then the next bond breaks, another hydrogen is added. So I need 2 moles of hydrogen to completely hydrogenate it. That is the key point here. To hydrogenate an alkene completely, you need 1 mole of hydrogen. If it is only 1 double bond, right? And to hydrogenate an alkyne, you need 2 moles of hydrogen to hydrogenate it completely. Hope the concept is clear. So here X is an alkene and Y is an alkyne. So X will require 1 mole and Y will require 2 moles of hydrogen to completely hydrogenate it. So that is the answer for that question. So I hope the idea is clear, the concept is clear. Okay, great. Now let's discuss the next question. Which of the following is not a straight chain hydrocarbon? A very fundamental question, but I would say this is very important as well. A straight chain hydrocarbon. Here you can see in this compound, this is a straight chain hydrocarbon, because here we are getting how many carbons? 1, 2, 3, 4, 5, 6. 6 carbons are connected at a stretch. So this is a straight chain hydrocarbon. Now in this compound also we have straight chain of carbon atoms. 6 of them are connected. In this case, option C, do we have any branching here? No, because here also the carbon atoms are connected at a stretch. There is no branching. But in this case, you can see that there is a branch, correct? Because here we don't have at a stretch of continuous carbons. The maximum at a stretch that you can get is this, and in that case, this will be the branch. Or I can select this as the straight chain, and then this is odd one out, right? This is a branch. So the one in option D is not a straight chain hydrocarbon. So I hope the idea is clear to everyone. So a straight chain hydrocarbon doesn't mean in terms of the shape. A straight chain hydrocarbon means a hydrocarbon where all the carbon atoms are connected at a stretch. It doesn't matter how or in what shape you draw it. You should have carbons connected at a stretch. So I hope this idea is also clear. Right. So we have discussed the most important questions from the chapter carbon and its compounds. So I hope you are clear with the questions and do revise the theory again and perfect this chapter. Thank you all.